Good morning. Welcome to the fourth lecture of this ongoing course on architectural graphics or engineering graphics. So far what we have already learned is what are the tools that we are going to use and how to set up your board and how to make borders on your sheet, how to draw the title block. And so from today we are ready to actually learn the language of graphics. So the first thing that we will learn is what are the different types of lines, and as I said that there is a standard language which we are going to be using, and this will not change, this does not change. If we make one particular type of line, it implies something. So today in this lecture we are going to look at the different types of lines which are going to be used in architectural graphics, and we will also learn about the different graphic symbols which will be used in engineering graphics and architectural graphics. Some of these symbols may not be of use to engineers, or some of these may not be of use to architects, but this is an entire set of graphic symbols that I am going to talk about today, so that either whether you are going to pursue an engineering course or you're going to pursue an architecture course, this subject will still remain relevant to you. So, we left this board yesterday in this manner, and if you notice, I covered the sheet with a butter paper, a butter sheet. You should always do this, you should make this as a habit, because the butter sheet allows this line not to smudge. It helps it to stay intact and your sheet will not get dirty. So always you should cover it with a butter sheet. At least a set of these sheets you should keep. Next thing that we will do when we come to start working on our sheet is to clean our instruments. Particularly the edges should be cleaned once every time you start working, because these edges, they pick up the blackness, the graphite of the pencil. So whether it be your set square or it be your T-pulley, we should always clean the edges, and the edges should remain clean. Once we have done that, we will start working on our sheet, and whenever we are working on the sheet, we should try not to place our hands on the sheet but the butter paper. So if we move the butter paper, our hands will still remain on the butter paper and the sheet will not get smushed. So what I have already done for you is I have drawn some of these lines, very thin lines, very faint lines, using the pencil to etch, because these are just guides. We are not going to be needing them later. These are just to guide us. So we are starting with the different types of lines here. I am using this pencil HB. I could also use a 2B because I have a firm hand, but you may always start with 2H and then go on to HB and then go on to 2B or whatever. So these are the guidelines that I have already in place, and I'll start with the first type of line. So the first line that we are going to look at is the visible line. Whenever in an object something is visible, it could be either in section or in elevation, we will draw continuous line which is called a visible line. Now this line that we are talking about is a thick line, because this is what we are going to be seeing. So whenever we draw on a sheet, we will have a thick visible line, and I am going to simultaneously write the different names for this. This one is a visible line here. All you have to do to draw a visible line is draw a straight continuous line. This is visible line. If a curve is visible, then you will draw a continuous curve, a curve in a continuous line. In case the same visible line is seen in elevation, there will be slight difference in the thickness. It will be dark, but it will be thin. So we will draw a thin dark line. There is a difference between darkness and thickness. I am making it equally dark, but it is thin. So, this is a visible line in elevation. So, we will have a visible line in elevation. Next, we have a hidden line. Sometimes some parts of the object may be hidden behind. So, it may be that there is a cavity in between, there is a hollow, and we are not able to see the inner parts. In that case, the hidden line is used, and hidden line is a dashed line where we have continuous dashes of equal size and spaced equally. This is again a thin and a dark line. So, there is darkness in it, but it is relatively thin as compared to the visible line in section. So, if you draw for architects, if you are drawing staircase, so the steps of the staircase on the first floor will actually be seen in this line, which is the hidden line, and it is also called the dotted line. So, here we will use the nomenclature as hidden line. This is also very commonly used in engineering. So, for engineers, if you are drawing certain machine where a hollow part is there, a hole is being drilled into the body of the object, then this line will be used, which is the hidden line. This is also used often. The next line which is often used is a center line. Center line is again having almost the same thickness as that of the visible line in elevation, and what we have in center line is that we have a long dash and a small dash in between. This is what the center line is. I will show you a drawing, a completed drawing, where we will also see that where is the center line and how is it used. But this center line is used to represent the center of the object in case there is a center. In case there is no center to it, we wouldn't be using it, but then this center line is often used for machines because most of the machines are symmetric about a center line. So, this is also a commonly used type of line. Next, we have dimension line. Whenever we draw an object, and since I said that graphics is actually a language, now if I have to draw, if I am making drawing of a residence and I say that the wall is 9 inches thick or 230 mm thick, in that case I will have to dimension the object, the part of the drawing, and which is where we will use a dimension line. Now, dimension line is thin, it is very fine, but it is slightly darker than, I will come to those lines, the darker than the leaders, darker than the guidelines, but lesser than the visible lines. So, this is dimension line, and I will also show how to draw the arrows and how to complete the dimension line, but for now we will only understand the different types of lines. So, our next lecture is on dimensions only. So, this is a dimension line. Next, we have a section plane line. A section plane line is a very thick line and which is also called a cutting plane. So, what we have in this one is we have a thick, very thick line, a bigger dash, then two smaller dashes. It is very similar to center line, but so this is what we use for the cutting plane line. So, whenever we are going to be drawing section for an object, that what will be seen if the object is cut along this particular plane, this is called, this line representing the section of that object, the plane where the section is being drawn, is called a cutting section line or a cutting plane line. And often you would find in objects that it is marked with an arrow. So, from when the object is being cut at this particular plane, which side are you seeing in the drawing is also marked here. Okay. Then we also have a stitch line. Now, the stitch line is very similar to the hidden line, but it is thinner and slightly lighter. So, we have equal sized dashes here, and it is called a stitch line. One more line which is often used is a break line. I will tell you the long break first. So, what we do, we make equal dashes and we leave some part in between, a dash size space in between. This is, and then in this break part, we draw lines like these. So, sometimes when a drawing is very huge, it is a big drawing, we can't probably draw the entire drawing in one sheet. So, what we do is we just draw a part of this object, draw a section line and then continue with the remaining part of the object and continue it on the next sheet. So, this is a long break line. This is often used in both engineering and architecture, and you will be using these break lines often. This is what you will use. And then the same dimension line, similar to dimension line, we also have an extension line, which is a very thin line. It is the thinnest line. So, very thin, thinner than dimension line, and this is called an extension line. These are the most common lines which will be required, which will be used by you. Sometimes we also use break lines for, say, curved objects, for example, hollow pipes. In that case, what we normally do is, if there is a pipe, there will be two parallel lines which will be drawn in elevation or in section, whatever. So, just imagine that this is a pipe, which is going to be cut, and at the cut end, we will draw a curved part like this, and it is then hashed. This is the break line, this is the mode, this is the standard for showing a break line for the curve. So, we can write it as the curve break line. So, these are some of the most common lines which we will be using. There is another one which is called phantom line, which we will see in the object. So, just consider this object which we are seeing on the screen. Now, this object is this is the main object which is in question. So, if you see here, this is the object line which is a visible line. So, this is the darkest line here. So, it means that this is the visible part of the object when we are drawing this object. Okay. Now, this object is symmetrical about this center line. So, if you see, there is a long dash and a small dash, then a long dash and a small dash. This is the center line. So, we have a center line here about which the entire object is symmetrical. Now, in this object there is a hole which is drilled. So, if you see it here, this particular curved part, a cylindrical part will be drilled inside. So, this is the hidden line which we are not seeing, but we know that there is a hole in there. So, this is what we say is the hidden line. So, if you see the nomenclature, these are the dashes, equal size dashes which represent the hidden line here. Now, this must be a curved part because we can see the break here. So, this is a break line which is used for the curve. Had it been a rectangular or a square part, then we would have used a different break line here. Now, you also see that there is a cutting plane line or a cutting section line. So, it means that the object is being cut from here when we are seeing the section. So, if we cut this object here and we look to this side, so when we cut it and see it from this side, we can see that there is a hexagon which is being cut, and that is why we see a dark line with shade, this hatch here. So, this is the hexagon. Then we have a circle which is marked by this. Then we have another circle which is marked by this. Okay. So, we are seeing, and we are seeing it towards this side, which is what I was telling you. When we draw a cutting plane line, we also have to mark an arrow to which side are we seeing. This is the center line we have already seen, the object line, the cutting plane line. Now, in case we have some dimensions to be mentioned, suppose I have to mention the dimension of this piece even after it is broken, I will extend this object, the edges of the object, which is what we see as drawn represented through extension line, which is the extension line, and this is the dimension line. So, dimension line is slightly thicker and darker than the extension line. Extension line is very faint. This is the dimension line. I told you that it is a straight line. Now, here will be a break where whatever dimension it has will be mentioned. The units for it will be mentioned in the title block. So, units will always be mentioned in the title block, the scale of the drawing will be mentioned in the title block. These are the common things. Also, if you see, when the object is cut at the section which we receive is mentioned as section AA, which is the section seen when the object is cut at the plane AA, which is the cutting plane line. This when we represent something, when we mark something, so all these lines are called the leaders. Now, I was telling you about the phantom line. So, phantom line is a line which is an imaginary object. Okay. So, we are assuming that though the main object in drawing is represented here, this particular object is going and fitting into another object which is not the concern here, but of course, we know that there is an object intended. This object is represented using this line called phantom line. So, we have a bigger dash and then two small dashes here, bigger dash and two small dashes, and it is drawn in very light. It is not very thick and dark, it is very light line. This particular line is called the phantom line. So, more or less almost all different types of lines are covered here, and I just hope that you understand what are these different types of lines. So, this was the first part which we were going to learn in this lecture. The second part is graphic symbols. Now, just assume that we are going to draw the plan of a house. Now, what material will be used in this particular wall or whatever section, whatever drawing we are making. So, those materials will be represented through graphic symbols, and which is what we are going to learn here. So, the one which is most common is that of a brick in section. So, assuming that there is a room and the walls of the room are being cut at say 1 meter level. So, what would you see? You would see these walls and they will be called brick in section. Suppose the walls are being constructed out of brick. So, this is brick in section. What we do to represent brick in section is we draw hashed lines at an angle, usually 45 degrees, and we draw two close lines and repeat them at an equal interval. So, this is the most commonly used representation for brick in section. When you are drawing it on your sheets, you can make small boxes and you can repeat these. So, this is the most common representation for brick in section. Now, brick in elevation. Suppose we have an exposed brick where the brick is going to be seen, the pattern of the brick is going to be seen. In that case, we will just have equidistant lines. We will draw the pattern as would be seen in elevation. That is the simple representation of brick in elevation. So, there is no section in it, it is just being seen in elevation. This is the exposed brick which is not being cut. This is brick in elevation, and sometimes when it is a plastered surface, the brick is being plastered, then in that case it will just be a blank thing, which is what we will be seeing here. So, these are different. This is brick in section, this is brick in elevation, exposed brick in elevation, and the plain one will be brick in elevation with plaster. The next we have concrete, the components of concrete. So, suppose you have PCC, plain cement concrete. So, all of you would be knowing that there are three components that go in the concrete. So, we have coarse aggregate, we have fine aggregate, and we have cement. All those three parts are represented for PCC, plain cement concrete in section. So, we first make the coarse aggregate representations. So, we have these coarse aggregates represented by small triangles. And then we have the fine aggregate, which is sand, represented by thicker dots. So, we have the fine aggregate represented by this thicker dot, which is say sand. And then we have very thin points, dots to represent cement, because cement is the finest material which is used in concrete. So, this is how we represent PCC, plain cement concrete. So, this one is PCC, plain cement concrete. Now, suppose we have to draw RCC, which is reinforced cement concrete. We use the same representation as PCC, because what is RCC? RCC is nothing but PCC plus addition of reinforcement. So, we will make the same representation as we did for PCC. We will make those triangles, we will make those thicker dots, and then we will make those finer dots. And then we will add the reinforcement, representation for the reinforcement. Now, what is reinforcement? It is these steel bars. Now, they will usually not be seen. So, we use the nomenclature of a hidden line while drawing the RCC. So, we will have these dash line, the hidden line representing the possible reinforcement which might be passing through it. So, this is the representation for RCC. Now, if we are just making a sand fill, in that case we would just have these thicker dots filling up the space wherever we are filling it up. Okay. So, this is how you would represent sand if there is a sand fill. So, we have done brick, we have done different components for concrete. Now, if we have earth, now earth can be used in multiple ways. There could be rammed earth fill, there could be just plain earth loosely filled. So, most common when you are doing flooring, you will be using the rammed earth. The rammed earth is represented by a hatch which is drawn like this. So, you have a hatch pattern which goes in different directions. So, we fill it up like this, and this is the representation for rammed earth. So, in case there is a huge area which needs to be filled up, you do not fill up the entire area with the rammed earth hatching, because it is not very fast unless you are doing it on computer. So, if we have to do it by hand, we will only fill up the sides of the box, sides of the space which is represented to be filled up with rammed earth. So, that is what we will be using. This is the representation for rammed earth. Suppose you have grass, there is a grass lawn. So, whenever you are designing, suppose you say that there is just a grass lawn. So, all that you do is make small V-like marks and fill that area up. This is for a grass lawn or just grass, which will be represented like this. Suppose we have random rubble masonry. So, if there are these bigger pieces of rock which are going to be filled up together, so you will just make these representations for random sized rocks, some small, some big. So, as the name suggests, it is a random rubble masonry. We do not have very distinct or defined way of packing them up, which is what we see here. This is called random rubble masonry. This is often used in walls, especially for the retaining walls. We also have a dressed stone masonry. So, dressed stone masonry is, if you see the forts from Rajasthan, you would see that they use random rubble masonry. So, you will draw very thin guidelines, and then within them we will draw these freehand representations for dressed stone. That is how the dressed stone masonry will be represented. This is dressed stone masonry. Another very commonly used material in our architectural work especially is glass. So, now glass could be seen in elevation, because most of the time we see glass being used in elevation. So, what we do in elevation, if you look at glass in elevation, it has nothing but just some reflection. So, we just have a plain surface and we will make 3 lines, freehand parallel lines, which represent the reflection. This is glass in elevation. So, all these graphic symbols which we are using are standard, and they are used like this, especially in India. These are the standard formats in which we will use. Now, suppose if the glass is cut, suppose there is a section and you have a section being made out of glass. Usually the windows are quite thin, so you do not have it, but in case there are walls made out of glass, all you do is you hatch that entire thing in parallel lines. This is but thin lines, very thin lines. So, this is glass in section. So you fill up that entire area. It is rarely used, but still, if you have glass being used as a structural member and there is a thicker part where glass is used, this is how you represent. It is also very similar to how metals are represented. Now, suppose if there is aluminum, it is slightly different, very similar but slightly different. So, you will have a thicker line and then you will have the next one is a hidden line, a dashed line. So, a continuous line and a dashed line is usually used to represent metals, especially aluminum. So, that is how we represent. So, we have a thicker line and then we have dashed line. This is for, so this is glass again in section, and this is metal, aluminum mainly in section here. Now, we also have wood, which is often used. So, suppose we have the wood in section. Suppose if there is a wood in section, then we would only use a section representation. So, if the wood is being cut, you would only see odd styled lines coming, and this is what we use as wood in section. While, so this is the representation for wood in section, and if there is wood in elevation, then you would see grains like this if it is a seasoned wood. So, you have to make some representation for seeing the grains in wood. So, that is wood in elevation. That is wood in elevation. So, these are most of the different materials that you would be using. We have some more materials. Suppose there is a rock section which is there. So, in case the drilling is being done and you have a very deep pile foundation which is going to be used, then in that case, how we represent rock sections is that we will have this combination of hatching, a vertical and a horizontal hatch which will be placed together. So, this is what we used for rock, and I think for insulation, then again we have, so this is mainly for the synthetic insulation that we use. So, we draw parallel lines and then we draw a pattern like this which represents insulation. Insulation is also now increasingly used in buildings. So, this is for insulation. So, that is what we are using as far as the symbols for materials are concerned. Next, if we are using the architectural, making an architectural drawing, so then we would require different types of symbols for representing the doors and windows. So, in case of, we will start with doors. If it is a single door, so we will make the representation for the wall where the door is going to be fitting. Now, this has to be on scale. So, if the wall is say 230 mm thick, now if it is a brick wall, we will have a hatch which will be representing the brick wall. You can complete this, section in this manner. So, this is the brick wall with the brick hatch represented here. Now we have to make, now this entire thing has to be on a certain scale. So we have to show the door panel, and here we can either use a 45-degree line, or we could also use a curve. So we could use a 45-degree line which represents how the door is going to be opening. So this is the representation for a single door. Now this single door, if it does not have any step in towards the inside or out, it implies that this is an indoor, a door which is placed indoors inside the building. In case we want to mention that there is a step outside, so we will make a line in the elevation which will be representing the step, not a staircase but just a single step. So this automatically represents that this is the outside and this is the inside. So this is the representation of a single door. In case for the same space, for the same wall, we have to use a double door. Of course, all this has to be on a certain scale which we have to be careful about. So what scale are you using? You have to know. So the midpoint of this entire line is where the door is going to close. Again I say there could be a curve, a quarter of the circle can be used here, or it could be a 45-degree line. So this is the representation for a double door. So this is a single door only inside, single door outside. This is representation for a double door which is opening like this. And when you are drawing this kind of a drawing, please mind the level of darkness. This line is going to be the darkest. So if I write in a descending order of darkness and thickness, this is the darkest because this is brick in section. And please remember that you will have to draw section lines on both ends of the brick. So you will draw section line on both the sides, whether it is here or wherever. So that's the thickest. The second is the hatch that we are going to use. That's going to be the second level of darkness. This is the third level of darkness, which is wood. Since it is very thin, you would usually not use a hatch in this, but it may be used if it is a big scale where you can see a substantial thickness of this wood. And then the fourth level of thickness is this path. So this is an imaginary line. This is not a real line which is going to be there. It's just an imaginary path which is being traced by the door panel. So this is these are the simplest types of doors. We also have some very specialized types of doors. For example, you would often find that we have sliding doors. So now these sliding doors could be sliding onto the wall. So we will have again the representation for the wall, and then we will just make a door panel which is representing the sliding here. So what we have here is this is the sliding door here. So we have the same representation for wall, hatch, and then this is the representation for a sliding door. So this door we could also show in very thin the traced path. So how the door will trace its path when it has to move in this position, but otherwise the door is in an open position, the door is going to be placed here. So this is the sliding door. There is another door, if you would have seen, it is called sliding folding. So, you fold it and you slide it simultaneously. So, what we have is, it is also called an accordion door. So, it is like an accordion. So, you keep folding the door and then you can slide that door. So, in an open position, this door will open up and cover this entire part which it is supposed to close. Otherwise, it will fold and it will slide onto one side. So, this is another type of door. Now, if you have window, so suppose I have a window. So, what do we have in window? We have a space which is open, there is an opening. Now, this part is actually in section. So, this is a brick in section which is, so this line is going to be the darkest, it is going to be the thickest. Now, there is a window sill which is seen here. So, this window sill is going to be dark but thin. So, we have this window sill which is dark but it is thin, and we have a glass which is cut in section. So, that is again dark but thin. So, that is the representation for a window. Now, if you have openable window, you will draw doors or the panels like the one which we have seen in door. So, we will have a representation for openable window. So, thin line and a window pane. So, this is how we will draw the window with an openable pane. Suppose we have fixed window, we can just draw it like this. In case it is a ventilator, suppose we have a ventilator. Now, the ventilator is not being cut at a 1 meter level. So, what we do normally? We will draw the dotted line because it is not seen directly. So, if we have a dotted line being seen, we will assume that there is a ventilator at a level higher than where the section is being drawn from. Or another way of representing a ventilator is that we draw the dotted line and we draw it like this. So, this would also mean that there is an exhaust which is going to be placed in the ventilator, but at a level above. So, this is what we use for ventilator. So, these are the typical window types and door types which we will be using. In addition to these, for architecture, we also use graphic symbols for plumbing accessories, for electrical accessories, which you will learn gradually, and these are all standard types which can be found conveniently. But to start with, these are some of the different graphic symbols which you will be using. So, I hope you have understood the different types of lines, their usages and the different graphic symbols which will be used. Thank you for attending this lecture, and see you in the next lecture where I will be telling you the norm for lettering, how to write on graphic sheets. Thank you.